Thank you everyone. Today I discuss about chemical properties of hydrogen sulphide. Hydrogen sulphide, it is H2S, that is the chemical formula. It has two replaceable hydrogen atom, and this hydrogen atom is displaced by metal and forms two types of salt, acid salt and normal salt. And that is why H2S is a weak dibasic acid. That means its basicity is 2. When it reacts with any hydroxide, that means alkali, it produces two types of salt. For example, when H2S reacts with sodium hydroxide, it forms sodium hydrogen sulphide or hydrosulphide as acid salt at first step, and in the second step sodium sulphide is produced as normal salt. Here sodium hydroxide, when reacts with H2S, this sodium atom displaces one hydrogen atom from here and forms NaHS plus H2, displace hydrogen and OH together forms this water. Now when this produces NaHS reacts with sodium hydroxide, then this sodium atom again displaces this hydrogen and forms Na2S, and displace hydrogen and OH together form water. So not only the sodium hydroxide, when H2S reacts with potassium hydroxide, calcium hydroxide, then also it forms the salt and water, and that means its hydrogen is displaceable, so it is a dibasic acid. Now the another very important reaction for H2S, hydrogen sulphide is acid and it is a strong reducing agent. So H2S is a reducing acid. When H2S is passed through chlorine water, it reduces chlorine to HCl and H2S itself oxidized to sulfur. Here the reaction chlorine plus H2S gives HCl plus sulfur. Here the Cl2 is reduced to HCl as hydrogen is added. H2S itself oxidized into sulfur because hydrogen is removed. So chlorine is reduced by H2S to form HCl and H2S itself oxidized to sulfur. So this reaction proves that hydrogen sulphide is a strong reducing agent. Now the another H2S is an acid, but it can react with the other two acids, nitric acid and concentrated sulfuric acid. Now question is why? H2S is acid, but it is a reducing agent. HNO3 and concentrated sulfuric acid are the two oxidizing agent. As H2S is a reducing agent, so it can react with nitric acid. Nitric acid is a oxidizing agent. When H2S reacts with HNO3, it produces nitrogen dioxide. But when H2S reacts with H2SO4, then it forms sulfur dioxide gas. Now the reaction H2S reduces nitric acid to brown color NO2 and H2S itself oxidized into sulfur. H2S plus HNO3 to gives NO2 plus S to gives H2O. Here the H2S is the reducing agent, HNO3 is the oxidizing agent. That is why these two acids can react to each other. Now when H2S reduces concentrated sulfuric acid, must be it will be concentrated sulfuric acid to form SO2, and H2S itself reduced to sulfur. Here also H2S is a reducing agent and H2SO4 concentrated sulfuric acid is a oxidizing agent, and that is why these two acids react to each other. Now the very important question is when H2S is passed through the ferric chloride solution, then what happens? The color of ferric chloride is brown. When H2S pass through that ferric chloride solution, then ferric chloride reduces to ferrous chloride, and color of ferrous chloride is green. So the brown color solution turns green. When H2S is passed through a brown solution of ferric chloride, it turns into light green solution of ferrous chloride, and here H2S is oxidized into sulfur. Now when H2S passed through orange colored acidified solution of potassium dichromate, then what happens? The color is orange, potassium dichromate. Here the potassium dichromate, this is the potassium dichromate, and it is the acidified solution. When H2S pass through it, it is the orange color. When H2S pass, then this orange color potassium dichromate is reduces to chromic sulphate, and its color is green. So orange color solution turns green. The reaction is K2Cr2O7 plus H2SO4 for the acidification of potassium dichromate. When H2S pass through that acidified potassium dichromate solution, it forms K2SO4, potassium sulphate, chromic sulphate, water and sulfur, and this sulfur comes from H2S by oxidation. That means H2S is oxidized into sulfur, where K2Cr2O7 it is reduces to chromic sulphate. So the orange color solution turns green. Now the very important reaction for H2S is the precipitation reaction. Why it is very important? When H2S gas is passed through the solution of certain metallic salt, the sulfides of the corresponding metals are precipitate, and these metallic sulfides have their own characteristics color, which helps to detect the metal ions present in it. And for this property, H2S gas needs for in a laboratory for detect the metal ion. For example, when H2S gas is passed through a blue color solution of copper sulphate, then a black precipitation of CuS is formed. H2S when passed through the blue color solution CuSO4, then what happens? This Cu displaces two hydrogen atom and forms CuS, and displaces hydrogen and SO4 together forms sulfuric acid, and this is the black color precipitation, and this black color precipitation helps us to detect it is the FeS. Now the same reaction, type of reaction, when H2S is passed through colorless lead nitrate solution. This is the lead nitrate solution, it is the colorless. When H2S pass through this solution, then lead sulphide is formed. Here the Pb displays 2 hydrogen and form PbS, lead sulphide, and derived, that means derived away H2S forms nitric acid with joining NO3, that means nitrate. Now the next is on passing H2S gas through colorless silver nitrate solution. Also here the black silver sulphide is precipitated. Here the Ag displays these 2 hydrogen and forms AgS, and displays hydrogen and NO3 together forms HNO3. So H2S when passed through the metallic salt solution, then it forms metallic sulphide, and the color of this metallic sulphide helps us to detect which metal is present there. Now how you identify H2S gas? Sodium nitroprusside, it is a colorless solution. When it comes contact with H2S, then the color of solution turns purple due to the formation of sodium thionitroprusside. Its color is purple. Sodium nitroprusside turns sodium thiosulfide, which color is purple with contact of H2S, and this chemical reaction helps us to detect H2S or to identify H2S gas. Now the very important 2 questions. When oil painting picture remains exposed in air, then it becomes dull. Question is why? Because of every oil paints contains lead compounds, and our air contains a trace amount of H2S due to the pollution. This H2S reacts with lead components present in oil paint and forms black colored lead sulphide. H2S reacts with lead compounds which is present in oil paint and produce lead sulphide, and this lead sulphide is black in color. So the picture will be blackish, that means its brightness decreases and looks dull. Now the another similar type of question, when silver object or ornaments does not use for a long time, then it looks dull. Now the question why? In the same, our polluted air contains a trace amount of H2S. This H2S reacts with silver particles and forms silver sulphide. Silver reacts with H2S and forms silver sulphide, and it is a brackish in color, and this silver sulphide is deposited on that silver particle and makes it dull. And this brackish layer also looks some yellowish in color because of for the formation of some sulfur particles. So silver object or ornaments becomes dull when it remains unused for a long time and exposed in the air because of H2S reacts with Ag to forms Ag2S, and this becomes this becomes dull, the silver object. Thank you.